Good afternoon, fellow climate realists. We're the realists in the world. We're not the alarmists, and we're not deniers, that for sure. I often say, when someone says you're a denier, I say, yeah, I deny that I deny climate change. I'm a denial denier. So, yeah, we're not deniers. Now, what I'm going to talk about today is Canada really warming at twice the global average rate, whatever that means, we're going to talk about that, due to greenhouse gas emissions? Well, that's certainly what the Canadian government says. They say, here's what they say. Canada's climate is warming twice as fast as the global average. So we're the poster child of global warming, according to them. Now, there's a few problems with that. My first question is this. How many Canadians would object? I left Ottawa 2 days ago in a snowstorm. Okay, how many Canadians would object if it was a bit warmer? I think not too many, especially since most of Canada is a frozen wasteland for much of the year. Okay, most of Canada, there's almost nobody living there for good reason. So we have to say, would it matter? 20 times more people die due to the cold than due to the heat, according to a paper published in The Lancet. So yeah, I mean, is it really a problem? Not for Canadians. And in fact, in Canada's Changing Climate Report, which came out in 2019, it's authored by Environment and Climate Change Canada and Natural Resources Canada. They even admit that. They say, in all cases, northern Canada is projected to warm more than southern Canada, and winter temperatures are projected to increase more than summer temperatures. So I don't know if there's very many creatures or animals or plants that would mind if it was minus 50 instead of minus 55. But, you know, that's what they're talking about. But they admit this. There will be progressively more growing degree days, a measure of growing season, which is important to agriculture, and fewer freezing degree days in lockstep with the change in temperature. So they actually admit that, yeah, this might be a good thing for Canada. But it's interesting because here's what they tell us in the climate change report. Since 1948, when nationwide records became available, Canada's annual average temperature, we'll talk about whether that really is a temperature, has warmed by a best estimate of 1.7 degrees. And they go on to say the same thing, except it's warmed faster in the Arctic. Okay, in the winter, oh my God, that's a real problem, 2.3 degrees. Now, they go on to say this. They not just talk about the past, they talk about the future. They say that we're forecast to increase the temperature anywhere from 1.8 to 6.3 degrees if it's a high emissions scenario. They say only the low emission scenario is consistent with holding the increase in global average temperature to below 2 degrees. Well, you know, I think, as I say, in Canada, we might actually ask ourselves, is that a bad thing for Canada to warm? Well, we have to also look at something that's been brought up a number of times, and that is there any such thing as a global average temperature? Well, I cite Christopher Essex and Ross McKittrick's book, a wonderful book that everybody should pick up. And they say temperature is not an amount of something like height or weight. It's a number that represents the condition of a physical system. In thermodynamics, it's known as an intensive quantity, in contrast to quantities like energy, which have an additive property, which we call extensive in thermodynamics. And in fact, there's a very interesting paper put out, and they give examples of how different kinds of averages, when you have temperature fields that overlap, can show warming or cooling with the same data, okay? But they do point out that the notion of globally hotter or colder does actually have some value, and here's an example they give. They say, for example, Miami in January has temperatures ranging from 20 to 30 degrees C. While in Toronto, it's minus 15 to minus 5 degrees C. Since those temperatures ranges don't overlap, then it doesn't matter what kind of average you create. It could be numeric average, it could be mean, it could be mode, it could be RMS. You're always going to get one warmer than the other because their ranges don't overlap. Okay, so it's independent of the kind of average you actually have. However, they say not so for the case of comparisons of Earth's supposed temperature field at times a few years apart. The range over the globe, about minus 80 C to plus 40 C, is essentially the same year after year with only small changes. And of course, the same thing applies with Canada. Okay, you compare one range of temperatures for a particular year with another one, and you find the ranges almost entirely overlap. Okay? So in this case, where ranges overlap, not all averages will over a given set of actual observations, will agree on trends, throwing the whole idea about warming or cooling into doubt. And of course, there's no super being straddling the planet that says, I feel hotter today. You know, we live in regions. It's important what happens where we live. Nevertheless, they say this: the annual average temperature, which they love to bring up, in Canada has increased at roughly twice the rate of the global average. Annual temperatures over northern Canada increased by more than 3 times, roughly 3 times the global average. Well, they immediately contradict themselves because a few pages later, they actually show an average temperature here, if I get the right, there we go. They show an average temperature way before 1948. I thought they just said they didn't have, well, they put it in there anyway. But the interesting thing is that when you compare it with the globe as a whole in the north, you see that 1948 is a very convenient year to choose because it was just before the warming of the 1930s. Okay, so they say, oh, it's because we don't have enough data before 1948. Well, maybe it's also because it was warm before 1948. we know the Dust Bowl, okay, it was hitting. And, you know, it's interesting because warming is a fairly normal thing to happen in the Arctic at various times. Tim Ball used to put this slide up. He says, look, this is a white spruce, radiocarbon dated to about 5,000 years ago. And it's located 100 kilometers north of the current tree line. So obviously, at some point in the past, it was warm in the Arctic, a lot warmer. So the whole idea that warming in the Arctic is A, bad, B, unusual, is simply a mistake. We also tend to become a little bit suspicious when we look at when the maximum temperature records were set for the different provinces in Canada. Let's take a look. Quebec, 1921. Ontario, pretty recent, 75. But all the prairie provinces and the Atlantic provinces set their maximum temperature records in the 1930s. Okay? BC was more recent. We get to the Arctic, we see much more recent records. Now, I'm going to focus on the Arctic especially because the Arctic of Canada, north of 60 degrees latitude, is about 40% of the whole country, okay? So if you can't show that it's warming in the Arctic at all, we'll see in a minute, then we really don't have much confidence about a temperature for Canada. Yet they say this is remarkable. We have very high confidence that the temperature data sets are sufficiently reliable for computing regional averages of temperature for southern Canada starting in 1900 and for northern Canada from 1948 to the present. So let's do a little digging in and see what kind of data do they have for northern Canada. Well, this is 1948. They had 14 stations. And 6 of those actually closed more than 10 years ago. Okay, so they don't have much in the way of constant temperature measurements. Northwest Territories, I should point out, is twice as big as Texas. Okay, these are huge, huge areas. And the whole area here that I'm showing, the Northwest Territories, the Yukon, and Nunavut, that represents 40% of Canada. Yet they still felt confident to draw these graphs and show that supposedly in Canadian Arctic, it's warming 3 times faster than the world. So I looked into the data that was used to write this report. And here's what we find. We find 13 data stations in the Northwest Territories. Now, these are not data stations that have continuous records. Only about 5 or 6 of them have long-term records. And of those, about half of those actually have records from 48 to the present. And yet they said they're very confident. With what? 3 data points for an area twice the size of Texas? I mean, it's crazy. You should compare it with the Climate Reference Network in the United States. These are pristine locations. They're chosen purposely to be a long way from urban heat islands. They have triple redundancy in the instrumentation, so if one temperature sensor fails, they still have 2 others. Okay, so they have a really good record here starting around the year 2000. So I thought, well, wouldn't it be interesting to compare Texas with the Northwest Territories on the density of data stations? You can see in Texas there's 8 CRNs, okay? And these are high quality, pristine, very, very good data stations. And look, there's Texas in comparison with northern Canada, and they have 8 in that area. Northern Canada, in fact, I'm going to focus on the Northwest Territories. As I said, there's only 2 or 3 in an area twice as big as Texas that even has continuous records for the whole period that they're very confident about is actually warming at 3 times the global average. And you also have to remember that you're comparing apples and oranges. These are very inconsistent records, okay? They've moved location. They've changed the time of day that they record. They've changed instrumentation. All kinds of changes go into this, so they have to do what they call adjusted, homogenized, interpolated, to actually come to any conclusions at all. So when you look at that, and you realize that that is the area of Canada that's supposedly warming faster than the rest of the country, and we have practically no data. They had no business claiming that they had very high confidence concerning the warming. I mean, I'm sure it must have been a politician that told them to say that. Because any scientist looking at the data would say, yeah, you have a few data points with some sort of a trend, but you really can't have very high confidence in what's happening there. I like to say that what's going on here is it's not evidence-based decision-making, it's decision-based evidence-making. And I'm about to show you probably the best example of decision-based evidence-making. This is the most recent version of the AHCCD, that's adjusted, homogenized Canadian climate data, and you'd say, my goodness, they have a lot more stations. But in reality, there are less stations now than there were in the previous graph. What they've done is they've taken stations that previously were considered unreliable. The data was too poor, it was too inconsistent. And they've brought them all back into the database, ending up with more stations, which they then apply all kinds of mathematical tricks to supposedly show us this. And what they show is that if you draw a straight line through the data, which doesn't make any sense, I'll show you in a minute why, you end up with, in fact, twice the world average, if you accept that there is such a thing. Now, we have to also be skeptical because we know from Tony Heller that around the world there's been a lot of manipulation going on. This is Iceland, for example. The raw data is the blue, and oh, look at that. Isn't that interesting? After they've manipulated it, they can show quite a lot of warming. Now, if we're going to suspend judgment for a second, let's play make-believe. Let's pretend that it matters that Canada's warming faster than the world. Let's pretend that we can meaningfully talk about an average temperature. Let's pretend that they really do have enough data and that the actual numbers that we're seeing and the graphs that we're seeing actually are a reflection of reality. Well, we have to then look back and see, oh, they're blaming it, more than half of it, they're saying, on greenhouse gases. Now, if greenhouse gases were the driver, we would see a very different sort of curve than this. This is the Canadian data using the most recent reference, the version 4, okay? Now, before 1978, we see that there's virtually no warming. 50 years of virtually no warming. And remember, we're making the leap in faith that all those 3 criteria are satisfied, which they aren't. And we see that since 1998, there's essentially no warming. So what's happened is there's been a step change in 1998. And greenhouse gases don't do that to the climate, okay? No matter what you believe, whether you think it's mostly or all, or if this is the major contributor, as Environment Canada says, then this is the kind of curve you would get if CO2 was the only driver. So you would expect to see some sort of reflection of this kind of a gradual rise, but you don't. These are many temperature records across Canada that go into their composite for the nation. And you can see that, for example, in this first one, it's a step, okay? We have almost constant temperature for, in the previous graph, 50 years, and since the year 2000, there's no warming. So what would cause that, okay? What would cause a step very different to what you'd expect from greenhouse gases? This, by the way, is the satellite measure of that region of the Earth, and it also shows the step. Well, this suggests that the temperature rise in Canada is not primarily greenhouse gases. There's something else going on. Because, of course, CO2 would not do that if it was the major driver. And this is exactly what Dr. Joseph Hickey, a PhD in physics, points out in his report on correlation research in the public interest. It's really worth looking up. This is a wonderful group, does a lot of similar work to Marcel's group, actually. But regardless, he took the curve of Environment Canada's data, and this is their data, and he said, what would happen if I got rid of that step? What would it actually look like? And he got the graph on the right, okay? It's over here. Now, what we find is that if you get rid of that step, you end up with a climate sensitivity of about 1 to 1/2, okay, somewhere in that range, which is a little bit more than what William estimates, but it's at least in the right ballpark. So this step, gotten rid of, leaves behind what may very well be greenhouse warming, but it's a lot less than twice the world average. Yet they take that and they actually project a straight line through it, which makes no sense at all because it's not a straight line. It's a step, almost constant temperature, a 1-degree jump, and then almost constant temperature. So it doesn't appear to be much to do with greenhouse gases. It's most likely ocean oscillations. Probably the 1998 step was largely induced by El Nino. Now, why has it stayed up there? Well, partly because, so Joseph Hickey believes, and I think he's probably right, that in fact, the positive phase of the Atlantic multi-decadal oscillation is still in force, okay? It started a little after El Nino, and it may go for another couple of years. Now, if that's the case, if the AMO is the cause of the temperature staying elevated, mostly in eastern northern Canada, then we'll see it come down again to the kind of line that Joseph had originally. Remember, he had this line. We may see it go back to this kind of a slope when the AMO is over. Just point out really quickly, it's interesting that in the data for northern Canada, if you go to the west, you also see a jump in 1975, which was the year when the PDO, the Pacific Decadal Oscillation, shifted into the warm phase. So our conclusion basically is that it's almost certainly not driven by greenhouse gases, but we also have to ask, do we really know what's going on in northern Canada at all, which is 40% of the country? And I'd say, no, until we have an analysis like Anthony Watts has done, we really don't know. Thank you.